Okay. I have 620 officially, and currently about 18 of you guys in here with me. And I waited 620 just to give people time to log in before we get started on the material. Something I do customarily, as I know most of you may be getting off for 9 to 5, and just to get everybody joined in. So I have selected to record this class. We'll see how successful that is, as this is the first semester in which I've utilized Zoom in the academic setting. Previously I've been using Zoom, but now using Teams. So we'll see how that works. And after we repost it's after the class. So right now, you guys should be seeing my screen as it relates to plan views, and you should be hearing me smoothly. If you cannot see my screen or hear me, please let me know before I continue. Okay. So we last left off looking at this plan as it deals with locating windows and frame walls. Now we're going to shift focus to elevations. And those elevations, we're going to be providing information about window types and the glass types. So elevation is going to provide information about the light size. And that light size is going to describe using two numbers, such as 24/60, 24-60, 24/60, or 24x60, or just 2460. So unless there is a window schedule included in the working drawings, and again, your working drawings just means your construction documents, the first digit in that number is going to represent the light width. The last digits are going to represent the light height. So for example, light width of a 24/60 window is going to be 24 inches, and the light height is going to be 60 inches. So any additional letters and numbers are often going to be used to provide more information. So when several windows are the same type and the same size, dimensions and the light sizes are not shown for each of those windows. So rather, this information is going to be indicated for one window with a notation indicating that that window type and size are typical. Okay, this is common. Window heights. So the vertical location of any window in a wall, they're going to be shown in many different places, including your sections, taken through an exterior wall, and taken through elevations. So any window height may indicate that from the finished floor level to the top of the window stool or inside the window sill, or also to the bottom of the top of the window jamb. As we look here in this figure 1-27, our dimensioning window heights to the top of the top window jamb is preferred since the top member of those windows usually align horizontally. So on the right hand side, we see top of the window jamb, 9 feet 6 inches to the floor. Window height to the bottom of jamb. And then our height, 9 feet 6 inches to floor. So when windows differ from your stock windows or right off the box windows or typical windows, so when they differ from your stock windows and it relates to trim or its installation, there's going to be a large scale detail shown on those prints. And it's going to be similar to what we see here that's shown by Rock Island Millwork. So this figure is going to show detailed section through a double hung window. And it's going to be taken from this manufacturer's catalog, Rock Island Millwork. Now, the portion of the drawing labeled jam is basically our section of that window side jam looking down that has been revolved into one place. Note that at the top of this window, or the top and the bottom sashes slide vertically in those grooves formed by the window frame members itself. And our rough frame members are shown as rectangles and diagonal lines. Rectangle and diagonal line. We see here blocking members, your basic 2-bys. Again, our window opening from there to there. And that rough opening is always larger than your window opening. Moving along to schedules. So our window schedules are typically included on your set of prints. Now, a schedule is basically a detailed list on a print that provides information about building components such as your windows, your doors, and any mechanical equipment. And a window schedule describes each window by its type, its size, and also any special features it may have, such as it being insulated or tinted glass. And also, but not least, the factory number. Now, a letter or a number code on the elevation or the floor plan and on the schedule identifies each window. Often, window schedules are combined with door information as a door and window schedule. So we see the code for window type E, F, G, and H. We're to buy 3, a window E, 2, a window F, 1, a window G, and 2, a window H. It's giving us the number of lights that are located in each one, the size of the glass, the sash size, the rough opening, and any special remarks related to those windows. Here we can see at a 1/4 inch equals 1 foot scale, a front elevation and a front framing elevation of that window member. So with this being window E, we know that there's to be a total of 3 of those. We know the glass size, 39 by 51 inches tall. And the second part of that light is 39 wide by 19 inches tall. Two lights, 1, 2. And again, that rough opening should be larger than the window itself. And that checks out. 3'8" 3/4 is greater than 3'6" in the X direction, and in the Y direction, the 6'8" 3/4 of an inch is larger than the 6'6" inches. Any questions so far? Okay. Now, moving to doors, we're leaving windows and moving to doors. We also have door classifications that include swinging, accordion, pocket, sliding, and even bifold doors. The symbol for swinging doors on plan views in a single line with an arc. A single line with an arc. This is how we represent doors graphically on construction documents, plans. So other symbols are used for other door classifications. So our door hand is the direction in which a door swings. Our door hand is the direction in which a door swings. So when determining door hand, the viewer always stands on the outside of the door. So the outside may be a hallway, or it could be a street side of an entrance door. So for doors that open between rooms, the keyed side of the lock is considered the outside. Again, for the doors that are open between rooms, the keyed side of the lock is considered the outside. Looking graphically, interior door, exterior door. One indication that we can tell that this is the outside door is by that member there. Short lip, right, to allow for runoff. Swinging door, accordion door, pocket door. There's a small pocket for that door to be hidden. Sliding glass doors we typically see leading out to patios and decks. And our bifold doors. Again, these are all plan views of those type of doors. And again, our door hand. So if someone is standing outside this left-hand door, you're going to more than likely use your left hand to open this door to get inside. A left-hand reverse, we're on the outside. We're going to use our left hand to open the door as it swings towards us and step back. What naturally occurs. The last two remaining types are right hand. We're standing on the outside. I'm going to use my right hand to open it and walk in. And similar to the right hand reverse, again, we're standing on the outside. I'm using my right hand to open up this doorknob. It's swinging towards me. I'm stepping back, then I'm going. Right hand reverse. Hinge. So go back, watch that, watch this video if that didn't quite stick. Let's double check to make sure no one had any questions in the chat as it relates to that. Alexa, 1 second. If someone's having trouble getting in. Hey, Luis.
Hey, yeah, so the question that I have is there a way, or is it more so just the aesthetics that determine the swing of the door, being, you know, outside versus inside, or is that just the design feature that they decide on when they just, when they're doing the blueprint or the design?
That's a great question. Thanks for asking that. So usually it's going to be aesthetics, but also how that door relates to inside items, be it furniture, uh, other items that may be architectural or even structural. So if your door is swinging this way, let's use this one for example, you have a permanent feature, right, or a focal point that you want the user to experience once walking through that door, you may want to have it swing this way and have that special feature located somewhere in this general area. So that's just some of the things that one might consider when choosing the swing of the door, right? Views, components, structure. So it's all going to be a point to think about. And remember, everything should flow well together, outside of how that door looks, but more importantly, how it functions. Excellent question. I hope I answered that for you.
Yes, sir. Thank you.
Yeah, perfect, perfect. Anyone else have any other questions before we continue? Okay. So looking at doors as it relates to classifications, we also want to look at the door types in general. So generally speaking, we have two general types of doors or door designs. And those two door designs are panel and our flush doors. So looking at this figure 131, a panel door is going to be a door with individual panels between the stiles and the rails. A flush door is going to be a door that with flat surfaces on each side. The stiles and the rails are concealed within the door itself. Panel, flush. Taking a step further, you can say, okay, this is a 4-panel door, this is a 6. Or this is a flush solid core door with the window. Or a vision panel. You also might hear that. Okay. Now, also related to doors, some doors are going to be designated as fire doors. Now, a fire door is a fire-resistant door in assembly. This is including the frame and the hardware, commonly equipped with an automatic door closer. Now, the 5 classifications of door openings with a door installation are going to be class A, B, C, D, and E. Now, those classifications are based on the time that a door opening withstands penetration of the fire. So, starting at E and working our way up for this fire door opening classification, we see in hours, it's going to take 3/4 of an hour's time, or what, 45 minutes, for this class E door and exterior walls subject to moderate to light fire exposure, 45 minutes. For D, should take an hour and a half for exterior walls subject to fire exposure from outside the structure. A C would take 45 minutes, which would include hallways and room partitions. A B classification door is going to take an hour and a half for enclosures of vertical egress in a structure such as stairways and your elevators. And a class A door prime time will be 3 hours for walls separating buildings or dividing one building into separate fire areas. This is where you see in mixed use buildings where you might have an assembly space or you may have another space that's functioning in a different manner. Okay. Fire door classifications. Now, the cores of those doors itself, their range. So we have a hollow metal door, which is going to be constructed using steel stiffeners in the core or using an impregnated craft paper. Foam, or we also have mineral blocking as the core. You want to see figure 1-33 that we see here. And one moment, guys, make sure. Okay, let's just, are you in here? You're not. So, he's having issues. So, sorry, guys. So when steel stiffeners are going to be using these cores, we're going to see steel channels being used, but also Z-shaped sections. Those also going to be installed vertically in those cores with foam, and any fiber insulation is going to be placed between those stiffeners. Now we also have steel face sheets, and they're going to be spot welded to those stiffeners to enclose those stiffeners in an insulation. So when using an impregnated material core, the steel face sheets are going to be laminated to the material using a structural adhesive. So minimum metal thicknesses are going to be specified for metal door faces depending on the door application, meaning where that door is immediately adjacent to. So for example, a 16 gauge door or an 18 gauge metal door Faces are going to be required for commercial applications, while a 12 gauge and a 14 gauge metal door faces are going to be required for your institutional applications. Now, our metal doors are typically finished with a primer at the factory, and those doors may also be finished with a baked enamel finish, an applied finish such as any vinyl cladding, any textural or any embossed finish such as a stainless steel or a polished metal finish. So numerous things you can do with this. Next, so per IBC, IBC is short for International Building Code, International Building Code. That applies to commercial construction. Now, the minimum width of those doors should provide a clear width not less than 32 inches that must be sufficient for the occupancy load of the building. The clear width of that door is going to be measured between the face of that door and the stop with the door open at 90 degrees. 90 degrees. When double doors without a mullion are going to be installed, one of those doors must provide a clear width that's not less than 32 inches. And the maximum width of the swinging door is going to be about 48 inches. Now, additional exits other than your elevators are going to be required where your occupancy loads exceeds a minimum number of people. So any special doors such as your revolving doors, sliding doors, your overhead doors, they may not be used as your permitted exits. Exit passageways must be at least 44 inches, except when serving an occupancy load of less than 50 people. Again, all this relates to the program or what that space is functioning as. So for occupancy loads less than 50, your exit passageways should be not less than 36 inches. We see how that drops. And also our landings must be accounted for. So landings must provide at all doors. It should be not less than the width of the door itself. And our doors in the fully open position should not reduce the required landing dimensions by no more than 7 inches. Now, our landings must be at least 44 inches long, measured in the direction of travel. And we see here all those elements which explain minimum width, the door from face to jamb at 90 degrees. When double doors are being used without a center mullion, that minimum width of at least 32 inches, max 48. Exit passageways and trying to evacuate people in moments of fire. We have 44 inches. The exit door must swing in the direction of travel. Why? People are leaving in panic. We don't want to impede that natural progress to flee and save lives. We also have for occupancies less than 50 people. So these will be places like your Starbucks, your Chipotle, which typically not going to get more than 50 people. They have a 36-inch minimum exit passageway we see here. When it boils down to trying to save lives in cases of emergency. Okay. Any questions before we leave the subject of doors? Hey, Louis.
Yeah, just one more.
Hmm.
In residential, is there a determination for sizes of doors within the structure? Like, I mean, I know that it's going to be occupancy under 50, obviously, but is there a minimum maximum there?
Correct. Great question. So yes, we're also going to see some regulation as it relates to residential as opposed that we see here in commercial. So you're going to want to see a minimum 36 is a good number, especially for exit doors. You're also going to see 32 for interior doors. But for residential places that may also be serving elderly or handicap, we'll see ADA framework to be used in those applications. So just think about, you know, how easier it would be if you had a wider door, especially coming from your garage into your kitchen and you're bringing all those groceries in. You're like, man, I wish I had a bigger door. So those are some of the design intent or thoughts one should have when thinking about spaces and how one proceeds between different spaces. Great question. Great question. Let's see. Make sure I didn't skip anybody. Anyone else? Question, comment, or concern? Hey, David, what you got?
Hey, so is this the same measurement for every single door for any door, whether it's big or small? Is like the same width or no?
What here in this commercial application?
Yes.
So not for every single door. Typically your exit doors. So depending on what type of building you're constructing or designing, for example, whether it's a grocery store, whether it's a fitness building, whether it's a mall, whether it's a
Oh, so the measurements change with the
the
width.
measurements change, right? For
Yeah.
interior doors. But
Okay.
a basic number that you're going to see here, right,
Mm-hmm.
is going to be applied for all those applications.
Okay.
You can't go wrong with a 3-foot door. You can't. But again, you want to check local building codes for wherever you're building at because that might change. They may be more strict.
Okay.
So that's why an architect is employed to know those things.
All
Okay.
right. Yeah. Thank you.
Great question. Yeah, no problem. Hey, Trevor, what do you got?
So I had a question about, like, say for instance about banks. Like, how would that work? Like a
Same
public,
difference.
like, let's say if it was in like Tampa or
hmm
something.
hmm How would the size of the doors make a difference?
Yeah.
So along with those double doors that we see or vestibule that I'm used to seeing in Chase banks that I worked on, those doors are counted as an exit, right? So in
Yeah.
those cases, those will be using what? Double doors, right? And they're going to be glass.
Yeah.
So there have to be an instance, okay, some of those have mullions down the center. That's going to be taken into account. But there's also a door in the rear or the side that's also a second exit because of that occupancy type or that type of program being a bank. So there's going to be usually more two or more exits for commercial spaces,
Yeah. Okay.
right? And then hopefully we get time to take a look at where do you go to find such things. And since we're here in Florida, we're going to be dealing with some of the Florida Building Code, and then learning how to search those codes for the type of building that you work on. There's restrictions or guidelines that you should follow when designing for it. Perfect question, Trevor. Thank you.
Thank you.
No problem. Anybody else? Dave, did you have something else? Got you. Still up. Okay. Great questions, guys. All right. So let's move to our stairs. Let's take a moment and look at stairs, and we're going to get down to even as it relates to details. But first, how are they depicted on plan views? Now, stairways are going to be shown on our plans by basic horizontal or vertical line, depending on which way that stair is traveling. Now, stairways are typically represented on plan views using a series of those parallel lines, as I mentioned, indicating those risers. Our risers are what? Points that rise up. Any notation such as our 14R, right? 14R indicates 14 risers up. R is for risers. And 13R down means 13 risers down. These indicate that the number of our risers to the floor immediately above or below, how many of those risers are depicted. Now, an arrow with the notation points up or down, depending on the direction of the travel itself. Basic clearances that we should also recall: 6'8" is a minimum headroom. Going up a stair, there should be 6'8" from edge of the tread to the opening. Should be clear. This is a 9 feet to 9 feet floor to floor height. We see 14 R for risers, and then we also see 13 R for risers going from the basement floor to the first floor. So floor to floor heights are a bit different between the basement floor and the first floor. And from the first floor to the second floor, it's at 9 feet tall. With that floor being 9 feet tall, your interior ceiling, floor to ceiling height, is going to be around 8 and some change, depending how thick that is. Maybe that's 6 and some change. So that's probably around 8'5" and something. Okay. Now, in our multi-story buildings, stairs may be either straight, known as our straight run. Stairs may also be a straight one with a landing. They could be an L shape with a landing. They could also be a U shape with a landing. We also see even an L shape with winders. It could be a U shape with winders, circular or spiral. Now, other shapes may be developed through a combination of those basic shapes. And it can get real intricate, real interesting, real fast. I'm sure we've all seen some varying degree of interesting stairs that's been designed out here, right? Well, those are your basic components. Now, minimum headroom, as I mentioned before, being 6'8". Architects must design risers in their treads to fit within those accepted dimensions and those code requirements. The biggest challenge is designing against codes or within codes and related restrictions in any given jurisdiction. Now, the preferred angle for a stairway is going to be anywhere between 30 to 35 degrees. Less of an angle produces large total runs. Deeper angles, they do not facilitate easy climbing. So there's a give and take that you play with there. Okay? Always keep that in mind. Now, minimum tread depths per IBC or International Building Code. We have also a maximum riser height. So minimum tread depth is going to be 11 inches. That's going to be measured horizontally between the foremost projection of the nearest tread or adjacent tread. That's how you measure the tread depth. Again, per IBC or International Building Code, there's also a maximum riser height. And a minimum riser height is going to be 4 inches measured vertically between those leading edges and adjacent treads. Hey, Richard, what you got?
Hey, sir, on the tread width, does that include the nose of the tread or not?
That includes the nose, yes. So say, for example, let's go to the side here. Say we have a tread, and as you mentioned, that nosing might want to do something special like that, right?
Yeah, that's what I'm talking about.
Right. So that should definitely account minimum.
Thank you.
Hey, no problem. Great question. That's correct. It should include the nosings. Again, always remember that measured horizontally between the foremost projections for that minimum depth. And the difference in riser heights and your tread depths in a stairway should not exceed no more 3/16 of an inch. And the minimum headroom for all portions of a stairway is going to be 80 inches or what? 6 foot 8 inches. 6 feet is 72 inches plus 8 inches, it gives you 80. Measured vertically from an inclined plane formed by adjacent tread nosing. Now, our landing on the floor or our floor must be provided at the top and bottoms of our stairways. Must be a landing. And that landing width should not be less than the width of that stair. If your stair width is 44 inches, your landing should be 44 inches. If your stair width is 80 inches, your stair landing should be what? 80 inches. Minimum. Landings must have a minimum dimension measured in the direction of travel equal to that stair width as I said, and should not exceed 48 inches where that stairway has a straight run. And the stairway should, let's say should, not have a vertical riser greater than 12 feet minimum between floors or landings. I repeat, a stairway should not have a vertical rise greater than 12 feet between your floors and your landings. Keep that in mind. Okay, Richard, do you have something else?
I'm sorry, sir, say again?
I thought you had something. I thought you had a question.
Well, I did the landing, you said 48 inches. That was based on what now? The width of the stairway or what was that?
Now, so the landing width should not be less than that stairway width, remember? And landings must have a minimum dimension measured in the direction of travel that's equal to the stairway width. It should not
Okay.
exceed the 48 inches where that stairway has a straight run. Should not
Yeah, I
exceed.
understand now.
Okay, no problem. Hey, Lewis, what you got?
So just to understand and verify what you were saying here. So you're saying that when you're designing a stairway, you can't go over 12 feet without a landing. So it has to be under 12 foot. If it's over 12 foot, you have to have a landing area, and then and then you can continue on. Say if it's like a commercial use where it's a long vertical, between floor type uh, stairwell.
Correct. So to just think about, we want to make it easy for people to navigate and travel between spaces vertically, right? If you have a 14-foot and beyond, people are just going to get tired, right? That's why we throw in commercial spaces like malls, those escalators, right?
Mhm.
Just think about in some malls, I think you see it even international mall, there's stairs, right? Those stairs have a landing. If they didn't have that landing, it's going to be quite taxing on us, especially these Americans here, right? It'll be like they're in the fitness room, right? So just giving people a break, a rest to gather themselves, and before going up. Again, it sounds silly, but that's correct. Take it easy on it.
Gotcha.
Yeah, I mean, great question. David.
Do you think you could repeat the vertical stairway? You had said something about a vertical stairway. And you said keep that in mind. I
Yeah.
would, if
So
you could repeat that.
yeah, sure. So the landing width should not be less than the stairway width. That being said, landings must have a minimum dimension measured in the direction of travel that's equal to the stairway width and should not exceed 48 inches where that stairway has a straight run.
Okay, thank you.
Okay, no problem. This is being recorded and this is going to be posted. So if anything you missed or it's not clear, just go back and take a here.
Okay, thank you.
And no problem, dude. Richard, did we get anything else from you? Maybe not. Okay. That's everyone. But last but not least, as it relates to details, wrapping up chapter 1, residential stairways are residential stairways. See, we have a detail here on sheet A5. This is detail 15 with a scale of 3 inches equaling 1 foot. This is our scale for this handrail alternate 2. So residential stairways should be a minimum of 36 inches wide, minimum, and the handrails must not project more than 4.5 inches on either side of that stairway. Again, minimum residential stairway should be 36 inches wide, and your handrails must not project no more than 4.5 inches on either side of that stairway. You have a minimum clear stairway width should not be less than 31.5 inches. So what? 31.5 plus 4.5 equals your 36 inches total. That minimum clear stairway width not being less than 31.5 inches wide when your handrail is installed on each side, or 27 inches when handrails are installed on both sides of the stairway. So our handrails must be provided on at least one side of the stairway, a minimum of what? 34 inches and a maximum of 38 inches above those tread nosings. So those tread nosings, lovely stair, you have those handrails that's on the wall. What we're saying is it should not be less than 36 inches, but no more than 38 inches above that tread. Now, a clear space that shouldn't be less than 1.5 inches must be provided between that wall, that adjacent wall, and that handrail. So we see that here. When you're grabbing that handrail, there should be at least 1.5 inches of space behind that cross-sectional or that bar or wood that you're grabbing onto. Now, the ends of handrails must return to be terminated at a newel post or even a safety terminal. Those cross-sectional areas of a handrail must be about 1.25 or even up to 2 inches. All right, that's the cross-sectional area. This is just looking at it from a plan view. Here's our gap space. We're grabbing that rail. Okay. Again, these are all standardized, and it all takes into account ergonomics in the human body, how it moves, what feels comfortable, right? That's been accumulated over years, decades, centuries, even going back before Da Vinci and all the greats. Ray, Richard, what do you got?
Hey, sir, so on the end of the handrail, it has to tuck back to the wall. Is that correct? So it's a closed and not an open end? I'd heard something about that, and I wasn't sure that's what was being described.
Yeah, that is exactly it. So if I'm looking here, I'm going to do a quick little sketch, right? So this is going to be my handrail. And this is going to be my wall. So that handrail, right? Let's start over. That's horrible, right? We can do better than that.
So while you're drawing that, I've got a 1900, early 1900 turn of the century house, and the handrail is just this long rod. So it's against code now.
Correct. Correct. And you'll run into a case where in those instances, since it's so old, they'll say, okay, you're fine. It's grandfathered in. We're not going to make you change that. Typically won't see them make you change that, right? But in cases if you want to do a remodel, and especially if it's an application where you're opening up to the public to stay in, they'll make you adjust that or modify that so it's up to code.
Understand. Thank you.
So you're welcome. And then here in this area, it will be that 1.5 inches we mentioned. That should be a minimum clear space so your fingers can just grab in there comfortably. And then here's our return areas going in back into the wall. Okay, so in your instance, you could probably just miter that end of it, do another piece, and then, either screw it, glue it, and bring it back into the wall.
Understand.
Okay. All right, guys. So that's going to wrap up our look at chapter 1. Again, I'll go back and repost our first live class meeting for those who might have missed it and pick up anything as it relates to chapter 1 and highlights that I want you guys to extract from it. Okay. Love the questions. Love the interactions. Again, feel comfortable to ask anything, whether it's a comment or experience you might have had as it relates to what we're dealing with, because it helps. Again, not only do I learn from you guys and you learn from me, but we're all learning, right? So we're going to wrap it up there. Again, look out Thursday for our recording as we move into actually chapter 2. Chapter 2, dealing with construction materials. Chapter 2, construction materials. And that will be posted this Thursday. Again, I make myself available if there's any questions on Thursday that you may have. Send me a message. I'll see it. I'll reply. Okay. So I may be backed up with messages. So again, if I haven't gotten back to you, trust me, I will. Other than that, guys, that's it. If you have any other questions for me, enjoy your evening. And if you haven't eaten yet, enjoy family time. Hey, Richard.
Thank you.
Hey, you're welcome. You're welcome.
Hey, sir, forgive me for asking
problem.
so many questions.
Love the
It
questions,
took me a
man.
while to figure out this team, so I was late. I don't know if you took roll call, so I'd appreciate that if you give me credit for coming in, but I was late. I'll be the first
Okay.
to tell you that.
Okay.
I'm just trying to figure out how to find you in this Teams thing. And then
Okay.
the second issue is I just also wanted to apologize as I learned the controls. I failed to lower my hand. I didn't know how to lower my hand.
No, you're fine. You're getting the controls down, and I like seeing the hand pop up there. And hey, we're all learning here, right? We're all learning.
Yes,
here.
sir. Yes, sir.
So
Absolutely.
if you see here, hopefully, I think some of you guys, Alexis, I see you're in here. So when our meetings come about, what you oh, Alexis talking to me now. So when you go here, a Microsoft Teams opening, this is what I see that you guys are looking at. I hope this is accurate. But when you go there, it should say join. You click that button, and it should give you to our sessions like we're doing now.
Yeah, that's my problem. When I go to Microsoft Teams, I don't have anything like this screen. I have an options page to use my browser or download a schools and workhouse account or do something else. And I finally stumbled my way through it to join the class here by going
Okay.
back to your 23rd announcement and tracing it down that way.
Huh. Okay.
Just use continue with your browser. That's gonna get you in there. That's what I did.
Yeah, that's how I get in. You continue through your browser. You just have to have Teams downloaded on your computer.
Okay,
Yeah, that's
thank you. I do have it downloaded. I just was struggling there.
Oh yeah, we all was.
Everybody was struggling.
Yeah, at the beginning, you know, it's easier now.
Okay. So are you saying last Tuesday class, that was it, you had to go there to access today's class?
Yeah.
That's how I did it. I just went back and traced it back, just trying to, because I'm not a member of your team apparently, and that's what I'm trying to figure out is how to become a member of your team.
Okay. I'll make sure I add you onto there, just so that that gets corrected. Let me make a note here. And Alexis, I see you. And 1 second, sir. All right, Alexis, what do you have? If you might be on mute, Alexis, if you're speaking.